Hi guys, and happy Friday. Today we're going to finish out our week of triangle basics by talking a little bit more in depth about isosceles and equilateral triangles. This is going to be on the foldable in your notes on page 4 in your notebook. When you're finished taking notes with my video, you're going to go ahead and complete the isosceles and equilateral triangle practice in 2 different places. You're going to do the problems on Canvas and answer them on Canvas, and you're going to write the equations and write your workout in your notebook on page 5. I'm going to check both of these places when I return next week. All right, before you open up your notebook, go ahead and look at the front flap where it says isosceles triangles. Let's review. So first of all, an isosceles triangle is a triangle that has 2 congruent sides. Those 2 congruent sides have a name. So let's go ahead and write the name on the front. It is called a leg. Because an isosceles triangle has 2 congruent sides, it has 2 legs. The non-congruent side is called the base. Just because it's called the base does not mean that it is at the bottom. Base in this case just means any side that is not congruent to any other side. So if an angle is formed by both a leg and a base, those are called the base angles. And last but not least, if you have the angle that is formed by the 2 legs, that is called the vertex angle. The vertex angle does not necessarily mean that it's at the top. It just means that it's the angle that is formed by the legs. So there's 2 legs, 2 base angles, 1 base, and 1 vertex angle. As we're talking about this vocabulary today, if you forget what it means, go ahead and open it or close your foldable and look at the front of this page. All right, go ahead and open it up, and let's go ahead and talk about some isosceles triangle theorems. So the isosceles triangle theorem says that if 2 sides of a triangle are congruent, all that's telling you is that that triangle is isosceles. So if a triangle is isosceles, then the angles opposite those sides are congruent. So what it means by the angles opposite those sides are congruent, those are talking about the base angles. So what this says is that if I know that segment AB is congruent to segment BC, then I can assume that angle A is congruent to angle C. All right, let's do that into an example. So look at example 1 right below this. It says to find the values of x and y. So look carefully. It doesn't tell me anything about this triangle, but it does because it tells me that these 2 marks are congruent, which means that these 2 sides are congruent, which tells me that the base is this guy right here in orange. And what that tells me is that this angle, that's 76, is congruent to this angle because they are the base angles. And because they're congruent, that means that if this angle is 76, then this angle is 76. So because I know that this angle is also 19x, I can go ahead and say that 19x equals 76. Which means all I have to do to solve that is to divide both sides by 19. So x equals 4. All right, to find the value of y, since I know that both of these angles are 76, I can do one of 2 things. I can say 76 plus 76 plus y should equal, what's the sum of a triangle interior angles? It should be 180. The other equation that I could have written is, well, since I know that there's 2 76-degree angles, 2 base angles that are the same, I can say 2 times 76 plus y equals 180. Choose one of those 2 equations and solve it. Next part that says converse. All right, converse, that is an old vocab word that we should know. To give you a little hint, hypothesis, conclusion, converse. So remember, the converse is when you take a statement that is if-then and you switch the hypothesis and the conclusion. So if we state what we just stated earlier, but in reverse. So this time, instead of saying that I know that the sides are congruent so the angles are congruent, it says that if two angles in a triangle are congruent, then those two sides have to be congruent. So if I know that angle A is congruent to angle C, then I can assume that segment AB is congruent to segment BC. So basically what that means is if I know that two angles of a triangle are congruent, I can say that that triangle is isosceles. All right, let's look right below it at example number 2. So this time in my example number 2, I was given that this angle and this angle are congruent. Can you identify which are the two legs of this triangle? So this side right here and this side right here have to be the legs. So this isosceles triangle is turned upside down, but it's still isosceles because the two base angles are the same, which tells me that these two legs are congruent. So all I have to do is say 5x equals 45, divide both sides by 5, and x equals 9. All right, this next theorem is a little bit different. Let's go ahead and read it and highlight the vocabulary words as we read because this has a lot of vocab words in it. If a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So let's go ahead and look at that word bisect. Remember, to bisect something means to cut it in half, or it creates two congruent parts. So this case, you're talking about a line cutting an angle in half. And it's talking about the vertex angle, the angle that is not congruent to the other two angles. So if you have a line bisecting the vertex angle, then that line is going to be a perpendicular bisector of the base. So the word perpendicular means that it is a 90-degree angle with the line. Bisect means to cut in half, and the base is the line across from that vertex angle. It's the one that is not congruent to the other two sides. So let's look in the picture to see what that's exactly talking about. So it's saying if I see that I have an isosceles triangle, so if I know that segment AB is congruent to segment BC, and it has two congruent angles at the vertex. So, and I know that angle ABD, which just for reference is talking about this angle right here, ABD, has to be congruent to angle CBD, and just for reference is talking about this angle on this side. Then I can go ahead and assume that BD is perpendicular to AC. And the other thing that it's going to do, because it's a perpendicular bisector, which means that it's going to create two congruent segments. So I can say that AD is congruent to DC. So if I know that this angle at the top is being cut in half, then that's telling me that the side at the bottom has to be cut in half. This is only true in an isosceles triangle. So let's look at number 3 and let's use this to find the values of x and y. So I have an isosceles triangle. Now this one is different. This one is backwards from what the theorem that we just read was, because I know that this is isosceles, and I know it's isosceles based on these two segments right here. I also know that this angle right here is a right angle, which means that this is perpendicular. Because it's perpendicular, that means that this angle at the top has to be congruent to this angle right there. It also is telling me that this part right here has to be congruent to this part right here. So because I know that these are congruent, that means that this angle at the top, x, has to be equal to this one right here. So because I know that this is isosceles, that means that the base angles are also congruent. So if this angle on the right is 28, the angle on the left has to be 28. So let's find the whole vertex angle, and then we'll find angle x. So to find the vertex angle, remember I can do 2 times 28 plus, let's go ahead and call this something else. Let's call it w, equals 180. So do 2 times 28 and subtract that from 180. So that means that this vertex angle, this whole thing is 124, but x is only part of it. So remember, it's a bisector, which means, so this whole thing is 124, which means that x is going to equal 124 divided in half. So 124 divided by 2 is 62. All right, to find the value of y, well, I notice that we already marked these two sides as congruent, which means that if the whole thing is 12, all I have to do to find y is do 12 divided by 2, which is 6. All right, nice. Let's go ahead and learn a little bit about equilateral triangles. Go ahead and open up the next flap. All right, so the next corollaries. Corollary just means a follow-up to what we already know. So if we know a triangle is equilateral, then we can go ahead and assume that it is also equiangular. We kind of talked about that the last time we were talking about equilateral triangles. So what that means is if I know that segment XY is congruent to segment YZ, which is congruent to segment XZ, then I can assume that angle X is congruent to angle Y, which is also congruent to angle Z. All right, so let's go ahead and look at the bottom. So it says to find the values of X. So since I know that all of these sides are congruent because they're marked, that means that it is equilateral. And because it's equilateral, it is also equiangular, which means that there are 3 angles that have a value of 3x. And all 3 of the angles should add up to 180. You also could have written it out the long way. 3x plus 3x plus 3x equals 180. Pick one of those 2 ways and solve it. So that's one way to solve it. Something else that we can talk about is because I know that all equilateral triangles are equiangular, that means that every single triangle that is equilateral has the same angle measures. Because I know that all 3 of the angles of a triangle should have a sum of 180. So let's go ahead and see if we can figure out what each angle in an equilateral triangle would equal. So if I called each of these angles x, and I added them together, x plus x plus x, it should equal 180. So that becomes 3x equals 180. Divide by 3. So x equals 60. Because 60 plus 60 plus 60 equals 180. Which tells me that every angle in an equilateral triangle is equal to 60 degrees. So let's use that information to solve for number 5. So because I know that number 5 says to find the value of y, because I know that this is an equilateral triangle, how do I know that? Well, these sides are all marked as congruent. Because I know one angle is 2y, I can say 2y equals 60 because I know that every angle in an equilateral triangle is 60. You also could have done what we did on number 1, or sorry, not number 1, number 4, where we could say 2y plus 2y plus 2y equals 180. Either way, you will get the same answer, so I'm going to divide both sides by 2. Y equals 30. All right, let's go ahead and do our last corollary to equilateral triangles. So if I know that a triangle is equiangular, then I can also say that it's equilateral. So if I know that angle X is congruent to angle Y, which is congruent to angle Z, then I can say that XY is congruent to YZ, which is congruent to XZ. Let's look at number 6. So because I know that all of these are the same, I can go ahead and set 6x equal to 42 because side is going to equal side. Equals 7. For the y, I have 15y. I know that it's equilateral, which tells me that these angles are all the same. So I can either say 15y times 3 equals 180. I could say 15y plus 15y plus 15y equals 180. Or I can say 15y equals 60 because I know that every angle in an equilateral triangle is 60 degrees. So go ahead and pick one of those equations and solve it. All right, let's go ahead and work on your Canvas practice.